In this video, we will look at logical operators in Dart, relational operators in Dart, and the conditional operator or the ternary operator. So logical operations, I think most of us have seen these before. That's the double equal sign to compare something as equal to each other, less than each other, greater than or equal, less than equal, greater than equal, and the not operator. So let's just quickly have a look at these simple printouts there. So print 10 equals 5. Now look at the double equal sign there. We are used to the single equal sign, and that is basically assigning a value to something. For example, if we said int x equals 10, that's a single equal sign, which means that I am assigning the value of 10 to x. So don't confuse it with this one. So this one is comparing. So a double equal sign is saying I'm comparing the value on the left with the value on the right to check if they are the same, if they are equal. So I'm testing, is 10 equal to 5? And if we print out this statement there, which is a Boolean statement, and you can see that statement evaluates to false. Or rather, that expression, the 10 equal 5 expression, results to false. This whole thing is a statement. Okay, so we've got 10 equals to 5. That expression evaluates to false. Why? Because we are asking the question, is 10 equal to 5? And in this case, it's not, so it will give you a false. Now, we can also do the less than and the greater than there. So we're basically asking the question, is 10 less than 5? And we know it isn't, so that's why it will give us the false. Is 10 greater than 5? Yes, it is, and that's why that one will give me true. Is 10 less or equal 5? Definitely not. Then also asking the question, is 10 greater than or equal 5? In this case, yes, it is greater. It's not equal, but it's greater, so it will also run true. And then the negate operator or the not operator, basically asking, is 10 not equal to 5? And that's true because 10 is not equal to 5, and it will return a true value for you there. Now you can see that we're using numbers here. So we've got a number on the left hand side, we've got a number on the right hand side, and try and use your logical operators in this way where you try and keep the types the same. So you can't compare strings with numbers. It's going to be difficult. For example, you cannot do this. I can't say print hello less than 5. I'm asking the question here, is the word hello less than 5? And I mean, just saying that out loud, it doesn't make sense. So just try and keep the same types on different sides of it. So I could compare strings also with the double equal sign there and say, let's say hello also, and run it and see what it gives me. It will tell me it's true because they are the same. But as soon as I try to do this, less than, so I'm asking, is hello less than hello? It gives me an error there that's saying the operator isn't defined for type string. So when working with strings, we're going to use something else. So when we're working with strings, I'm going to use the compare to method. So let's work with Adam and Eve here. So I'm going to say Adam dot compare to, and compare to the string that I want to test it against. Let's call it Eve. So if I have Eve as Adam as well, and I do the print out here, you will see it prints out a value of 0. So I know that if these two, if the value that I get there is equal to 0, so I'm testing if the value is 0, then I know the two are exactly the same. So if I run it quickly now, it will tell you, well, it's true, because the two are the same. So if it gives me a 0 value, I know they are the same. So I can test for the value of 0 to find out if two strings are the same. So you can see the compare to method. If you click on it, it compares this string to another. Returns a negative value if this is ordered before the other. So it's going to be a negative value if this one is before that one in the alphabet. So let's take Eve there, and let's just see what it prints out for us. So if I run this with Eve, it's going to print out a -1. And that's what they're saying here. It returns a negative value if this is ordered before other, which means that Adam is ordered in the alphabet before Eve. It will give me a negative value. So if I want to check that, I can just say if it's less than 0. And in this case, if I run it, it won't give me -1 because I'm testing if it's less than 0, and it's going to say true, which means that Adam is less than Eve, or Adam is first in the alphabet and then Eve second. And it's also true for the other way around. If we run it again, we will get -1. Let's put Eve here, and we put Adam there. And we run it again, and then you can see it's a positive value. So then if they say if it's a positive value, this is ordered after other. So this one is after Adam in the alphabet. Okay, so we can test for that by saying greater than 0. So just for interest's sake, how did they get to that? So let's use a print statement. And there's a helpful method called code unit at that will help us to check the integer value of the specific character. So for every character, there's an integer value that represented in coding as well. So I'm going to print out a capital letter A there, and you'll see the integer representation of an A will basically be a 65. So in this case, let's have it Adam again here, and let's have Eve that side. So when comparing two strings, they start with the first character, the A, and then the E. So I'm comparing the A, so printing out the A as a 65. So let's have 65 there. Compare it to the E. So let's see the value of a E. You will see the value is 69. So I'm testing a 65 and a 69. And you can see the difference. This one is smaller than that one. So if the value is smaller, it's first in the alphabet, and if it's bigger, it's later in the alphabet. So you could see this as a minus or a subtraction here by saying 65 minus 69 will give you a negative value. So if it's negative, in this case it will be true because it is negative. 65 minus a 69. And also the other way around, if we compare with Eve first, then it will be 69 minus 65, which will give you a positive value. And that's why we can test for greater than. So just a simple method that we can also get the integer representation of these values and make a bit more sense of this compare to method. So you can use the compare to method to check whether two strings are the same by using the double equal sign there equals 0, or you can use less than to check if the first one is first in the alphabet, then the second one, or the greater than, which means the second one is first in the alphabet and the last one is last in the alphabet. Right, some other interesting print statements that we can also have with strings here. We can also have, let's say, Adam, and I can use the length method. Now the length method gives me, if I print that out, the number of characters, 1, 2, 3, 4 characters, so it prints out 4. So I can test then if the length is greater than 5 as an example, and run that, and it gives me true or false. So yes, you can, with some methods, you can use the same operators. All of those operators can be used with the length, with the compare to, and maybe some other methods also. So we will dive a bit deeper into strings later on when we use them and look at some different methods that we can also compare strings with. Right, let's go to the relational operators. So the relational operators are basically the and the or operator. So let's look at an example quickly. It's just a simple print statement again. So we could have something like 10 less than 5 or 5 less than 2. Now let's quickly evaluate this one. So we're basically testing and saying, is 10 less than 5? So in this case, let's look, just have a comment above it. Is 10 less than 5? No or false. And then at the same time, is 5 also less than 2? So is 5 less than 2? It's also false. So if I run this now, let's look at the output there, and you can see it's false. So basically the or statement is evaluating both sides of it, and in this case it evaluates false and false. So basically, is 10 less than 5 or 5 less than 2? And for both it is a no, which means that's false. But if I change this one to a greater than 5, then this part becomes true now because 10 is greater than 5. The right hand side is still false. So let's just read it in normal English terms that says, is 10 greater than 5 or 5 less than 2? Yes, 10 is greater than 5. So which means that if we run it now, it's going to run true. Why? Because one side of the or is actually true. So we could also change this one to a greater than, and then that one will be true as well. And if we run it again, you will see that because both sides are true, it will also be true. So for an OR operator, the following is true. If you've got true on the left-hand side with an OR and true on the other side, your answer will always be true. If you've got false on this side and true on the other side, your answer will always be true because it's false or true, and that becomes true. Then if we have, for example, false or false, both sides are false, then we will get false because it's either this side or that side is false, it will give you false. So if you read, for example, 10 less than 5, 5 less than 2, is 10 less than 5 or 5 less than 2, both will be saying no. So that will be a no. That will be a false. And then the last one, so we've got true, true will give you true. False, true will give you true. And also if we have true, false, it will also give you a true value. So basically the only time this OR operator will give you a false is if both sides of it will be a false value. Right, let's look at the AND operator. So let's say we use the print statement, basically the same thing. We're going to say 10 less than 5 and let's say 2 greater than 5. Now if we print out this one, you will see is 10 less than 5? Definitely no. So let's have a false there. And is 2 greater than 5? Also false. So if we run it, you will see it's false. Now let's test something else. Let's say if 10 is 10 greater than 5, yes it is. Is 2 less than 5? Yes it is. Which means we've got a true, come on, and a true. And if we run this, just by actually reading it out loud in English, 10 greater than, is 10 greater than 5 and 2 also greater than 5? Yes, my answer will be yes. And that gives you a true. But if any one of these two sides is actually false, the whole thing will be false because we're saying and. This one be true and that one be true, then only it can be true. So if we look at this same thing again that we did this side, for the logical or the relational operator and, if it's true on both sides, yes, you're going to get a true. But if it's false on either side, you will get a false. So that one will be false and this one will also be false. So only when you've got both sides true will your AND operator give you a true value. If there's false on this side, false on that side, or false on both sides, you will get a false. Now let's just have a quick look at operator precedence here. So your logical operators has got precedence over your relational operators, which means that this side and this side executes first before they're testing the OR operator or the AND operator. So just keep that in mind, that the left-hand side and the right-hand side will be evaluated first, and then it will look at the OR operator. So logical operators has got precedence over relational operators. Right, let's have a look at a simple example now. So we could say something like, just before the print statement, int age equals 50. And let's say the double income equals 2,000 Rand, $2,000. Now, we could have a Boolean expression here that says something like, if the age of the person is greater than 60, or the income is less than 3,000, we will give this person some discount at the shop. So let's run this quickly. So this guy's age is 50, which means it's not greater than 60. It's less than 60. Or the income is less than 3,000. So is the income less than 3,000? Yes, because it's 2,000. Now what's the rule about the OR? The OR evaluates both, and if one of the two sides is true, this whole thing will print out true. So we see that the right-hand side here is true, and that's why we give the true there. And also, if you just look at this in normal English, we're asking if the age of the person is above 60 or his income is less than 3,000, we'll give him discount. So his age, no, definitely not above 60, but his income is low enough so we can still give him a discount. Now we could also say, but now in our company we won't give them discount unless their age is more than 60 and at the same time their income is also less than 3,000. So if we run it now, you will see it gives me a false there. Why is it false? Because for an AND to get the whole thing true, both sides must be true for AND to be true. If only one of the two sides is actually false, then this whole thing will be false. And we can say, or we can see here, because the age is 50 and 50 is less, is less than 60, it's not greater than 60, this part will be false, and that makes the whole thing false. All right, let's go to the last one there, and this is the conditional operator or the ternary operator, and it looks something like this. You've got some Boolean expression on the left-hand side, so this could be something like this one, this whole one, it could be that one, it could be this part there, it could be any one of these. So it's basically testing something or asking a question about something, and that's where the question mark comes from also. So basically, if the expression is true, it's going to be this value. If the expression is false, it's going to be that value. So let's look at a simple print statement to illustrate this. Just get some more space here. Let's say we're going to say the double mark, the mark for a test is 44%. Then we can print out the following. We can say something like, test first if the mark is greater than 80, because if it's greater than 80, we want to give him a distinction. So the question mark there is after evaluating this, is the mark in fact greater than 80? In our case, it's not. What will be the value if it's true? So let's say we're going to say distinction. And then if the value is false, we will just say passed. So we'll change it on later on, change it a bit more so that we get some other values as well. So sorry, not the comma there, but it must be the colon. So it's basically saying print the mark. Is the mark greater than 80? In our case, no, it's not. So the question mark, and then this should be the value if it's true. That should be the value if it's false. So in our case, is mark greater than 80? No. So it will not print out distinction, but it's going to print out passed. So if we run this now, you will see it print out passed. If we change this mark now to a 95 and we run it again, it will print out distinction. So we're evaluating the Boolean expression to see which one of these two to be passed in or to print out. So we could also have a variable here. So we can have something like string output equals, and then have this whole value there. Copy it, I paste it, put a semicolon at the end, and then instead of printing out that, I will be printing out whatever is saved into that variable. So now you're asking, but why is it a string if we are evaluating a Boolean expression? But remember, the type that we declare it depends on what gets sent back. In this case, it's a distinction or passed. And because this distinction and passed is both strings, I will save that output as a string. Now let's see how we can make this a bit more complicated. So I'll have another output. So let's say that's output 1, and this is output 2. And we're going to do the same thing again. I'm going to say test first if the mark is greater than 80. If it is greater than 80, I'm going to keep it at a distinction. Then if it's not greater than 80, that's what will happen on the right-hand side. So sometimes it's just a value that you pass through, and sometimes you can do a whole new expression on the right-hand side. So what I'm going to do here is to evaluate that value again. So I'm going to say if mark is now greater than 50. So there I tested. If the mark is greater than 80, then it's distinction. But if it's not, I want to test again. And I'm going to test if the mark is greater than 50. Now remember the question mark again. Then I will say passed. Because if it's greater than 50, it's passed. And then if it's not greater than 80 and it's not greater than 50, it means this guy failed. So I'm going to pass in failed there. And let's print out 2 now. So in fact, what we did here is to say this part is the evaluation first. So I'm evaluating mark greater than 80. If it's true, it's going to be distinction. But if it's not true, it's this whole part. And that whole part is again another conditional operator or ternary operator, which means I'm going to evaluate the whole thing again. Is the mark greater than 50? Yes, it is. Then it's passed. If it's not, the guy will be failing. So let's test this out quickly. So let's put a value of 40 there, and it should print out failed. Let's put a value of 65 there, which should be more than 50, so it should be passed. So just note it's more than 50, but it's not more than 80, so it won't show us distinction. And now we can make that a 90 and run again, and that will give us a distinction. Right, that's it for this video. Hope you're okay now with logical operators, relational operators, and the conditional operator. See you in the next one.